Assalamu alaikum, my dear students. I hope all of you are fine and having good health. So today we are going to discuss about the types of solids. Basically, mainly there are two types of solids. We have two types of solids. Number one type, we have amorphous solids, and the second type of the solids we have it is the crystalline solids. So these solids are different from each other as they look like both as solids, but their main or the basic properties are differ from each other. So let's have a look on the first type of the solids we have. It is amorphous solids. When we talk about the amorphous solids, basically these solids in which the particles are not regularly arranged. Regularly arranged means there is no pattern of the arrangement of the particles, or in simple words we can say that the amorphous solids are one that lacks the ordered arrangement of the particles. If there is no ordered arrangement of the particles, then we call the solids as amorphous solids. They have the picture like this. In this picture, we have the amorphous structure of the glass, that is silicon dioxide SiO2. Here you can see that the arrangement of the particles is not specific or not a regular pattern. For example, if we're going to talk about the regular pattern, we must see that the particles are arranged in a proper pattern. But as this is the proper pattern of the particles, but in this we have just seen that there is no regular arrangement of the particles and they are not properly arranged. When the particles are not properly arranged, then their type of solid we call it as the amorphous solids. And the particles are not arranged in three dimensionals. They are not arranged in three dimensions. It means they do not have 3D structures or three-dimensional structures. These solids are called as the amorphous solids. So let's have a look the more properties of the amorphous solids. Mainly the amorphous solids, they are hard. As they are hard, so they are like the true solids. But one thing they lack, it is their sharp melting point. They have no sharp melting point, then they just melt over a range of temperature. So they do not have the sharp melting point. For example, we have a lot of amorphous solids around us or in that we use in our daily life. The first example we have glass. It is the amorphous solids. Second we have the wax. Third one we have the butter. The fourth one we have the plastics. Fifth one type we have or the example is rubber. Sixth one we have the cotton candy and etc. All these are the amorphous solids as they look like this normal or the true solids, but in view of their structure they are amorphous solids because they lack the regular arrangement of the particles or they lack the 3D dimensional structure of their particles. Next, we have the crystalline solids. So basically, amorphous solids was lacking the arrangement of particles. On the other hand, the crystalline solids is the inverse of the amorphous solids. These are the solids in which all the particles are arranged in a regular manner or in regular three-dimensional or 3D pattern. As in this picture, you can see that we have a cube where the corner is having the fixed yellow one particles, and in the center we have the red one particle. So this structure we have a three-dimensional structure, and all the particles are having a regular arrays of the particles or 3D structure. So crystalline solids are mainly known as the true solids because all the particles are arranged in a regular manner. Next, we have topic allotropy. Before this, we will discuss the crystalline solids and their properties. So the property we have, they have definite surface or they have definite faces. They have sharp melting point. It's mean they melt on the exact melting point. So the pure crystalline solids do not get soft, rather than they have sharp melting point, means these solids are changes into the liquids at the specific melting point. They have definite shape and they have the regular pattern of the particles. Now these particles may be ions, these particles may be atoms, and these particles may be molecules. For example, we talk about the example of the crystalline solid, it's NaCl. NaCl, this is the table salt. It is known as the sodium chloride. It is having three-dimensional structure and it is the crystalline solid. Next, second example for this we have naphthalene. It is also a crystalline solid as it is having the three-dimensional structure of all the particles in a regular way or in a regular pattern. So this is all about today's lecture, and in the next section we will discuss about the allotropy. This is also the property of the solids as well. For that time, have a good day and Allah Hafiz.